Okay, sorry for the interruption. Here network is not stable. You can see here the pattern multiplication of 1 and 2. Okay, and the resultant radiation pattern is treated as an X. Similarly, from the radiational characteristics of 3 and 4 is combined as a Y. Okay. See here the length of the antenna, which is having lambda by 2. Okay, the same is already proved in the earlier class. Okay, cos of beta d cos phi by 2. Okay, what are the principal maximus and minimus? Okay, from that expression we obtain here like this the radiation characteristics. Similarly, when we consider the length cos of beta d cos phi by 2, in that d is substituted lambda there. Okay, where d is substituted lambda. Okay, then what is the resultant radiation pattern of that combination x and y? Is the group pattern. Hmm? Now see here, this is the four resultant radiation pattern of 4-element array. Okay, I will share that video. Okay, don't worry. Uh, Similarly, the same concept is applicable to 8 elements also. 8-element array. Okay, this is the 4-element array. This is the 4-element array. The same concept is applicable to 8 elements also. Okay. Okay. Then how to perform that radiation pattern calculation from the 8 elements when we consider the 8 elements 1, 2, okay, 3, 4, 5, 6, 7, 8. Okay. See here, already we found out what is the resultant radiation pattern of that 4 elements 1, 2, 3, 4 as a group, 5, 6, 7, 8 as a group. See here, 1, 2, 3, 4. 4 elements radiation pattern is already okay, the radiation pattern. Okay, and this is also from 1 and 2 combination. Okay, 3 and 4 combination, 5 and 6 and 7 and 8. Again from 1 and 2 combination to 3 and 4 combination, and 5 and 6 combination to 7 and 8 combination. Okay, again then what is the end to end length of the resultant x and y? Okay, then we have to find out the radiation pattern of that group and the radiation pattern of that single antenna element. Okay, the same concept. Okay, I will share that problem also. Okay, don't worry about it. Here the pattern multiplication concept, which is applied here, suitable to only the point source antennas having identical excitation, and the current applied to those current elements is uniform. Okay, equal current must be used to excite those point sources. See here, what are those excitation amplitudes of that current? Okay, excitation amplitudes. Okay, those excitation amplitudes are measured with or simply found out by using okay, that is simply find out by using this binomial array. Okay, okay. Already you know what is the binomial expansion. Okay, here one simple technique is there to find out what are the uh, coefficients, excitation coefficients. All these methods are not required for us, but regarding to the radiational characteristics, you have to learn pattern multiplication method and the binomial array is enough, okay, as per our syllabus. Okay, then what is the purpose of this binomial array? Just like in pattern multiplication, we found what is the resultant radiation pattern of array of antennas. All those antennas are equally excited, but it is possible to obtain the resultant radiation pattern if those point sources are excited with identical current magnitude. Okay, and here the theme behind this is okay, excitation current magnitudes plays a key role in drawing radiational characteristics of that group of antennas. That's why to find out uh, excitation levels or excitation amplitudes, the concept of binomial array is used here. See here, binomial array. In case of a uniform linear array, especially to increase the directivity and gain, okay, the array length has to be increased. Okay, and how many number of, just like a multi-stage amplifier, okay, and how many stages you are used. Based on this, we get total gain. Okay. If you want more gain, we use more number of amplifiers. Similarly, here also, if I want high directivity and high gain, then I have to use preferably uh, okay, large array length. But here the problem is, but when the array length is increases, okay, the secondary or side lobes appear in the pattern. What is the drawback of appearance of these side lobes or minor lobes? Okay, when the number of side lobes increases, then directivity and gain in desired direction decreases. That is the problem. Okay, that is the problem. And to avoid that problem or to increase the directivity, especially in one direction, okay, then I have to use excitation current amplitudes are identical or proper. Okay, to achieve this binomial array or a binomial coefficient is preferred. See here, but when the array length increases, the secondary or side lobes appear, and because of the side lobes, directivity decreases. Okay, in some of the special cases, okay, it is desired to have a single main lobe with no minor lobes. How it is possible? Okay, just I want only one main lobe. Okay, I don't want any side lobes or minor lobes or back lobes. Okay, then what I have to do? Okay, that is also possible with by controlling the current excitation of those point sources. Okay, with the proper amplitude levels. Okay, to find out that the current amplitude levels, just I am using that binomial array here. Okay, so that means the minor lobe should be eliminated completely or reduced by minimum level as compared to that main lobe. To achieve such pattern, the array is arranged. Okay, that group of array antenna elements are connected in such a way that the broadside array is radiate more strongly at the center than from edges. Okay, just it looks like, for suppose this is the array antenna. This is the array antenna. That array antenna having one main axis. Okay. Uh, okay, maximum radiation occurs like this. Okay, maximum radiation occurs like this. Okay, instead of the side lobes, just cross this side lobes like this. Okay, and without the side lobes, just I want main lobe only. Okay, to achieve such pattern, the array is this is the array is arranged in such a way that the broadside array radiates strongly at the center than from edges. Okay, that is the point here. See here. See, the same is explained with graphical method. See here, to achieve such pattern, the array is arranged in such a way that broadside array radiates more strongly at the center than from edges. Let us consider array of the two identical in-phase point sources. Okay, spaced apart lambda by 2 distance. Okay, here remember we always prefer the distance as a lambda by 2 is the standard antenna. Length of the antenna is a half-way dipole, that is considered as a standard antenna. Okay, then far field pattern is given by E equal to cos of phi by 2 cos theta. Okay, the same is derived earlier. The resultant radiation pattern of the antenna which is having a length of lambda by 2. Okay. Similarly, the same case, the pattern multiplication we discussed earlier. Okay, pattern multiplication discussed earlier is uh, do the same here. Okay, again it contains the four antenna elements. All those are point sources. All those point sources are excited equally. Then what is the resultant radiation pattern according to that binomial array? See here, in case of uniform four element array, the resultant radiation pattern shows four side lobes. Okay, that is the point. Okay, that is the same radiation character obtained from the pattern multiplication earlier. Okay, having four side lobes. See here, it contains two main lobes. Okay, two main lobes like this. Again, another two. Okay, another two from 0 to 180 degrees, and two on both sides. See here, in case of uniform four element array, the resultant radiation pattern shows four side lobes from the radiation characteristics, and the secondary side lobes. Okay, the secondary side lobes are also there, but they are not significant. Okay, simply they lost directivity in desired direction. That is the problem here. Okay, see here, because of the side lobes, okay, the net directivity is decreases. See here. So four element array, the elements producing patterns are spaced as a full wavelength part. Okay. Actually, the spacing between these point sources is considered as a lambda by 2. In that group pattern, what is the distance between x and y in that four element array? Okay, that distance becomes lambda by 2 plus lambda by 4 plus lambda by 4 from the diagram. Okay, that's why we get the distance as lambda. What is the radiation pattern of that lambda? Again, that resultant radiation pattern contains four lobes. Okay. Just I am multiplying those two. That's why I get side lobes okay, appear more than unit pattern. So if we want to reduce the spacing between the two elements to one half length, okay, one half wavelength, okay. Earlier, unit pattern is pattern for length of lambda by 2, and group pattern is for lambda by 4 plus lambda by 4 plus lambda by 2. But if I want to reduce the distance between the point sources as a lambda by 2 instead of lambda, then it is possible to get strong radiational characteristics from the same group of antennas. See here. So if we reduce the spacing between the two elements of one half wavelength, then only the primary lobes are obtained. Okay, and the minor lobes are completely suppressed. Okay, that is the point here. See here. Okay, what they will do to reduce the length of lambda by 4 on either side. See here again we consider the 4-point sources. Okay, here again we consider the 4-point sources as 1, 2, 3, and 4. These 4-point sources are spaced apart at distance of lambda by 2 each. Okay, lambda by 2, lambda by 2, lambda by 2. Here, the technique to reduce the distance between the point sources on group result as simply I'm combining, and because of the separation between the 2 and 3. Okay, why? Because here and that pattern multiplication will not consider the distance between the 2 and 3. Okay, generally the 2 and 3 distance is lambda by 2. Okay, here 1 and 2 is lambda by 2. Here 3 and 4 is lambda by 2. 2 and 3 is also lambda by 2. But when I am superimpose that 2 on 3, okay, when I am superimpose that point 2 on 3, okay, what is the distance between 2 and 3 here now? Same superimposition of that 2 on 3, then I get distance between the 2-point sources is 0. Okay, the distance between the 2-point sources are 0. Then do the same pattern multiplication method again. See here, just leave it and explain you again. Just 1, 2, and 3, and 4. Okay, what is the distance between 1 and 2? Lambda by 2. Okay, again 2 to 3 is 0. Again 3 to 4 is again lambda by 2. Okay, it is again lambda by 2. Then what is the distance between half of the point x to point y? Okay, this is lambda by 4 part, and this is the lambda by 4 part. The net distance is lambda by 2. Okay, see here the same is performed here. This is the point source 1, point source 2 and 3, and point source 4. Distance between 1 and 2 as a lambda by 2. Okay, spacing between 3 and 4 is also a lambda by 2. Okay, what is the radiation pattern of that combination 1 and 2 is like this. Again 3 and 4 is also same length. Okay, same 0 to 180 degrees. Okay, and the net distance between again lambda by 2 to lambda by 2 group pattern result, that is also like this. That's why when we multiplying that unit pattern into group pattern, unit pattern into group pattern, then we get the radiational character is like this. Okay, is it contains any side lobes? Is it contains any side lobes here while comparing with pattern multiplication direct method? Okay, in this method there is no side lobes. Moreover, the resultant radiation pattern is very strong compared to that method. Okay, in this way we are able to achieve, okay, strong radiational characteristics from that antenna. Understand? Okay, what is the difference we are observed from that pattern multiplication to this binomial array? In pattern multiplication, the resultant radiation pattern is obtained by multiplying unit pattern into group pattern. Okay, in this binomial array also we are obtaining the same, but here uh, the side lobes occur in that pattern multiplication method is suppressed by superimpose or merging point sources in between first and last. Okay, and in order to reduce the length of the resultant element. Understand? Okay, that is the point one. See here, arrangement of four elements with lambda by 2 spacing. See here, pattern of 2 element array and 4 element array. Okay, what is the resultant radiation pattern here? Okay, the same concept I explained earlier now. Okay, first one is the method, and the same is explained okay, during that example is for just 1 to 4 and 4 element arrays. See here, and it is not possible to draw here. When two elements or arrays are spaced at a distance of lambda by 2, such array produces increased radiation pattern with no secondary side lobes. Here antenna 2 and 3. Okay, here antenna 2 and 3 coincide at a center. Okay, that's why I superimpose it 2 and 3. Hence, it can be replaced by a single element. Okay, and just I am combining the 2 and 3 antenna elements. Okay, that's why it is able to produce the double current compared to the other elements. That's why it is able to produce the strong radiational characteristics than individual. Okay. The same concept can be extended further by considering the three elements array as a unit, and which is second one and is similar to, okay, and this is always possible with identical magnitudes excitation of uniform linear array. Okay. Must see here, and especially from this binomial array, we found out the current excitation amplitudes by merging the intermediate points. See here, when we consider three element array, just listen carefully, it is very important. Okay. When you consider the three element array, one, just take one plus one. So one must see here, when we consider the three element array, just when we consider the three element array, then the current excitation amplitude is like this. Okay, this is called binomial expansion. Okay, one. Okay, just take the one here, take the one here, 1 plus 1, 2. Okay, 1 plus 1 2, again the same 1. Okay, similarly I take the 1 here. Okay, 1 plus 2 3, again 2 plus 1 3, again 1 here. Okay, again, and this is the excitation for 4 element. Again 1, again 1 plus 3 4, 3 plus 3 6, again 3 plus 1 4, and put last one here. Again 1, again 1 plus 4 5, 6 plus 4 10, again 6 plus 4 10, again 4 plus 1 5, again 1. See here, 1 1 2 1 1 3 3 1 1 4 6 4 1 1 5 10 10 5 1. See here, when the number of antenna elements are increases, then the resultant excitation amplitude, these are the current excitation amplitude coefficients. Okay, current excitation amplitude coefficients when we use binomial array to get highest directivity or to suppress side lobes. Okay, and these are the current excitation levels we are using to excite that point sources in order to obtain higher directivity. Okay, that is the point here. See here, 1 2 1, same. This is the 1 2 1. Again, for suppose I'm using 4 elements, the same concept is further extended by considering the 3 element array is a unit, and with the second similar 3 element array spaced about a half wavelength. Here assumption is the spacing is always lambda by 2. The resultant 4 element array, excitation amplitudes are 1 3 3 1. Okay, see here 1 3 3 1. Okay, how that 1 3 3 1 I get from that expansion is, okay, this is called triangular method. Okay, this is called triangular method. Okay, by using this triangular method we are able to get any amplitude. Okay, and any how many number of antenna elements are used, then it is easy to get the excitation amplitudes. Okay, for suppose if we consider the 9 element, just it is expanded. Okay, this is for 3 element, 4 element, 5 element, this is for 6 element. Similarly for 7 element, 8 element, 9 element is also possible. For suppose 1 2 3 4 5 6. Okay. Next, can you draw the same for, okay, 8 element or 7 element array? Just 1 1 plus 5 6, 6 plus 5 10 plus 5 15. Okay, 10 plus 5 15, again 10 plus 10 20, again 10 plus 5 15, again 5 plus 1 6, again 1. Okay, this is the way of expansion of obtaining current coefficients to excite the point sources in order to get highest directivity and suppress side lobes or minor lobes. Okay, already you know that side lobes and minor lobes difference. Okay, this is called a triangular method. Okay, this triangular method is used to find out that coefficients. Understand? Is it clear from that pattern multiplication and binomial array? See here, that is the expansion for 4 element array. Here that tabulation method is not, okay, the triangular method is not mentioned, but it is very important. What is the difference between tracking and searching? Tracking and searching. Already I told you the difference between that torchlight and laser light. Torchlight is used for a searching purpose, whereas laser light is used for a tracking purpose. What is the difference? Okay, the difference here is beam width. Okay, so the narrower the beam width, directivity is very higher. Okay, for suppose the beam width is very large, then directivity is very poor. That is the relation. Similarly, the same concept is applied here. Okay, The same antennas are also used in radar applications. Okay, radar applications and satellite applications. So the next concept is phased arrays or scanning arrays. Okay, so the concept is discussed in the next class. So what we'll learn in today's class: pattern multiplication, and binomial array. Okay, this concept is very important in the final examination also. This is the uh, 7 marks question directly. Okay, that's all for today. I will continue in the next class. Okay.
హలో, నేను రంజిత్ సార్ నమ్మా. హలో హలో, am I audible?
Yes, sir.
Am I audible? హలో.
Yes, yes, sir.
యా, ఏంటి
Yes, sir.
అది కాదు, క్లాసులు వింటున్నారా లేదా క్విజెస్ అసైన్మెంట్లు సబ్మిట్ చేస్తున్నారా? నిన్న డికా క్లాస్ జరుగుతుంటే నలుగురు క్విజ్ సబ్మిట్ చేశారు ఆ టైంలో. మీరు క్లాస్లో ఉన్నప్పుడు క్విజ్ ఎలా సబ్మిట్ చేశారు? ఇప్పుడు సార్ క్లాస్ అవుతుంటే నాకు 3 అసైన్మెంట్లు సబ్మిషన్ అయ్యాయి. ఎల్ఐసి రవికుమార్ B8 నీకు కాల్ చేయమన్నాను. ఎప్పుడు క్లాస్ అయిపోయాక చేస్తాడు ఎవడైనా. క్లాస్ రన్ అవుతుంటే మీరు చేస్తుంది ఇదనమాట. అఫీషియల్ గా దొరికారు అసైన్మెంట్ సబ్మిషన్లు, క్విజ్లు. మీకు అంటే మీరు ఈ టైంలోనే అన్ని చేసేయాలి. ఇక 11 తర్వాత అసలు మీరు మీ టైం ఇవ్వరు మాకు. 11 తర్వాత మీ టైం మాకు ఇవ్వరు. ఇంకా ఈ టైంలోనే అన్ని చేసేయాలి. ఇంకా ఆ తర్వాత మీరు మరి ఆఫీసులకు వెళ్తున్నారు, జాబ్ చేస్తున్నారు వెళ్ళి. మరి క్లాస్ అవుతూనే ఉంది, నాకు అసైన్మెంట్ సబ్మిషన్ నోటిఫికేషన్లు వస్తున్నాయి ఎడ్మోడోలో. మీరు క్లాస్ వింటున్నారా, ఏ అసైన్మెంట్ ఇది చేస్తున్నారా? నిన్న అంతే 4 క్విజ్ సబ్మిట్ చేశారు సార్ క్లాస్ అవుతుంటే. ఇంకోసారి రిపీట్ చేయొద్దు ఇలాంటి చెత్త పనులు. ఫైనల్ వార్నింగ్, మిగిలిన టైంలో చేయండి. క్లాసులు ఇచ్చింది క్లాసులే. మీరు ఎట్లా ఉందో తెలుసో, క్లాస్లో రాస్తుంటారు కదా, మేము క్లాస్ చెప్తుంటే లాస్ట్ బెంచ్ లో కూర్చొని రికార్డ్ పేపర్స్ రాయటం, అసైన్మెంట్ రాయటం, ఆన్లైన్లో కూడా ఏ దొంగ పనులు చేస్తున్నారు.